Okay, right here, what did you do? There's many ways to go. Did you break up 405 into a factor tree? Not a tree. I don't do the tree thing. What is 405? What factors did you pick? 81 times? 5. Okay. 81 times 5, and then you have x to the 5th, y to the 4th. Now from here, there's 2 ways to continue. You can start square rooting right here, right now. Why would that be wise? Is there a perfect square root in here? Look, 81 and 5.
Yeah.
What's the square root of 81? 9. So look, I can literally go like this. The square root of 81 is 9 on the outside. True, everyone?
Multiply that by 2, right? Because
What?
multiply that by 2.
No, but you can't do that because
Remember, we're just square rooting.
it's to the
Oh, you're saying it's the 4th root?
Yeah.
Shoot. Shoot. Okay.
It's a perfect it's a perfect like.
Oh, no. So you're saying 4th root. I wrote square root. No wonder we're all confused. So right now we have this. Do you want to keep going then?
It's a perfect.
Okay. So it is a perfect 4th root. I don't have my perfect 4th roots memorized, so I just move on. So then I have a 9 times 9 times 5. X to the 5th, y to the 4th. Yes?
Yes.
So then I have the 4th root of 3 times 3 times 3 times 3 times 5. X to the 5th, y to the 4th. If this is me on the test, I then, before I move on, check. Is that 405? If not, I messed up, right, everyone?
Correct.
Okay, now from here you pull out groups of 4. So I pull out a 3. And how many groups of 4 are there in 5?
1.
X to the 1. So then let's actually put our radical and write a 4th root so we don't get confused. What was remaining with numbers? 5. And now what's remaining with x's? X to the 1. How many groups of 4 are there in 4?
1.
So y to the 1. And done. How many of you got it right? Nice. We get better as we go. All right.
I forgot the 4 right there.
Here we go. A few more. Cube root. Does this get an I?
No. Yes. No, it's not because it's
Nope.
odd.
So this is the cube root of. Do you want to? Okay. Everybody go. Do you want to do it by yourself first? Okay, go then.
I want to do one with an I.
Okay, we'll get there.
I know how to do it.
What is that number? Is it a 1?
This one has it. Never mind. Let's see. Respectfully, I think this.
Oh wait, okay. I might have to write this one out.
That's fine. If you ever have to revert to writing it out, no problem.
Let's see, it's just negative 1 times 3 times 3 times 3 times 3.
Why are you flexing?
What's the cube root of a negative 1?
Negative 1.
It's just negative 1, right?
The negative just stays one side.
Nope. We always either pull out an I or a negative. We don't leave it underneath.
Yeah. And then B to the second inside.
Yeah, negative 3b to
I did it! I'm so proud of myself. Right here.
And I was like, honestly, this is just not worth it.
Yes.
Okay. Okay, what do you guys think? Are you ready to see my answer? Here's my answer. Negative 3b cube roots of 3ab squared.
I'm so proud of myself right now. Yes.
Okay, good? Okay, let's keep practicing. I think you're getting the picture. Do you want, this will be the last one, and then we're moving on to the next topic. Focus, ready, go. I need everyone to really focus and not talk and get it right, and then compare to your neighbor. So right now, math is all about staying focused to not make small errors. Right now, on this one, I need everyone to not make small errors. Focus, go.
I've got.
Wait, is that a K?
Okay.
This is my work.
Some of you are way quicker than me.
I just don't do my work. See what mine looks like.
I can't see that far.
It's just the.
I'll come walk around. Okay.
I like to do it in my head too.
Well, not the equation. It's the answer.
Let's go, brother.
Just waiting for a few more people to get their answer before I show my answer so we can compare. How many of you have an answer just so I know where we're at on timing? Okay, a few of you just need more time. Okay, are you guys ready for me to unfreeze it?
Yes.
To see the answer?
Yes.
Okay, let's see if you got it.
Yes. Yes.
Let's go. I got it.
Should I get this?
I think I'm
Did you write it as 2 squared?
I'm pretty good.
Yeah, I mean, 2 squared is more simplified as 4, but
So do it as
I would. All right, what are your questions on this? Is this feeling hard or easy?
It's easy.
Now, once again, if it's feeling hard for you, go back to the old-fashioned way of writing it out until you really get the hang of it and pull out groups of however large, okay? All right, write this down. Now, everyone's listening because I'm teaching something new. All right, so now we're going to be adding and subtracting. Don't talk, don't talk, don't talk, or I'm kicking you out. You're going to be in Mr. Jones's class. Okay, when adding radicals, we can only add like radicals. Just like when adding x plus x, you can only add them because they're like terms. Isn't that just 2x, everybody? What's x squared plus x squared?
X to the 4th.
Nope. What's x squared plus x squared?
2x squared.
2x squared, right? You just combine like terms. Does that make sense, everyone? All right, what's 2xy plus 3xy?
5x.
You guys, this isn't a trick question. 2 apples plus 3 apples is how many apples? 5 apples. You don't change the apple.
Wait, why is x squared?
Wouldn't it be 2y? Because there's
What are you saying? You guys know that x squared plus x squared is just 2x squared. So you're just adding numbers. That's like adding 2 plus
the
whatever.
bottom one, there's 2
I thought that was
y's.
x.
Yeah, that's 2y.
So
No.
Oh,
You're
that's
you're
X.
double dipping.
Yeah.
This is just like terms. Look, 2 apples. Is this not an apple? Yes. Is this not an apple? How many apples do you have? 5 apples. You don't change the apple. This is not multiplication. Do you see the difference?
Yes.
Okay, this is not the same thing as this. Everybody look. Now do my xy's change? Yeah, it's multiplication. Addition, it does not change the variable. You can only add up like terms. Can you add 2x plus 3y? No, that's an apple. That's an orange. You guys, basic math. All right, so now write this down. To add radicals together, you can only add up like radicals. What makes it a like radical is the root is the same and underneath is the same. I'm confused why people aren't writing that down. You guys suck at taking notes.
Sorry.
I am. Shots fired.
Once again, when adding radicals, you can only add like radicals. To figure out if it's a like radical, the root has to be the same and underneath has to be the same. And then that's the apple. The apple doesn't change when adding radicals or subtracting radicals. Once again, the apple doesn't change. So let's look at root 2 plus root 2. Everybody listen. This is 1 apple plus 1 apple. Are they both apples? Look, is it the root and underneath the same?
Yes.
So how many apples do we have?
4.
No. How many apples do we have? 2 apples. The apple doesn't change. So that would be, you guys, this is the apple. You guys understand what I'm saying, right?
Yes.
So we have 2 apples. You do not add underneath the radical. That's not how it works. These are just like terms. Root 2, 1 root 2 plus 1 root 2 is just 2 root 2s. Does that make sense? Do the apple thing if you have to.
It's like, it would be like.
Okay, let's look at it again. Root 3 plus root 3 is how many root 3s? 2 root 3s. Can we add these? Root 7 plus root 3. This is 1 apple. This is 1 orange. They can't be added. Does that make sense, everyone? Okay, right here. What's root x plus root x? Yeah, 2 roots of x. You'd say this is 1 apple plus 1 apple is 2 apples. All right, look at this one. 2 roots of x plus 3 roots of x is how many roots of x? 5 roots of x. 2 apples plus 3 apples is 5 apples.
Those were.
Okay. All right, let's keep going. Keep looking with me. Can we add these? This is 3 apples plus 5 apples, which is how many apples? 8 apples. Does the apple change? So it's 8 square roots of 2x. Circle done. Are you making sense of this? Let's look again. 8 root 7s minus 4 root 7s is how many root 7s?
4.
Yep, 4 root 7s. True, everybody?
Yes.
8 apples minus 4 apples is 4 apples. Okay, here we go. Now look at this one right here. Only add what you can add. Oops, that's too small. There we go. 10 root 3s minus 4 root 3s plus 5 root 3s minus 6 root 7s plus 2 root 7s. So this is 10 apples minus 4 apples plus 5 apples. True?
9 apples.
9 root 3s.
It's
11 apples.
What the heck? So it's 10 minus 4, isn't that 6? 6 plus 5 is? So we have 11 apples. Now look, we have minus 6 oranges plus 2 oranges.
Minus 8 oranges.
No, that's not minus 8.
Minus 4.
Minus 4 oranges, done. What are your questions? Now,
-6.
okay, now here's what you have to make sure you're careful of. Okay, let's see another easy one, and then I'm going to point something out. Okay, what's the answer on this one right here? Think before you speak. Think. Before you speak. It's not a trick question. I just want you to think before you say the answer. Are these apples?
Yes.
They are, right? Look at the radical. Look underneath. Are they the exact same? So they're all apples. So can they be added? Yes. How many apples am I talking here? 1 minus 4 plus 7. So 1 minus 4 is -3 plus 7 is 4 apples. So 4, and then what would we write? Cube roots of 2x. All right, now listen. This is what you're going to see on the homework. Look at this. If you need to write this in your notes, do. Now, when you look at it right now, would you agree it looks like an apple, an orange, and a banana?
Yes.
But the problem is, this is a trick question. You cannot tell if something is like terms unless all of the radicals have been completely simplified down. So we first need to check, is this as simplified as it gets? Can root 5 break down?
No.
So we're good. 3 root 5 is 3 root 5. but can 24 break down? So now watch. This is a times sign right here. You guys all understand when something sits next to it, like when they're just sitting next to each other, it's a times sign. We know that. Okay, so right now we have this. 2 times the square root of, what's 24? 6 times 4. True?
Yeah.
Now, is anyone mad if I go like this? I know this is the same thing as 2, and then the square root of 6 and the square root of 4. I'm just going to square root these in sections, so I don't have to write them all out. Okay, what's the square root of 4? Okay, I'm not doing that. Never mind. You guys are not able to think that way yet, which is fine. This is 6 times 4, yes? So then we have 2 times the square root of 6 is 3 times 2. And then we have times 2 times 2. Yes or no?
Yes.
Then we pull out groups of? So we're pulling out a? What's already outside? A 2 is already outside, so don't we have a 4?
Oh, that's what I meant.
And then left under the root is 6.
Sneaky.
All right, and then we have this one, isn't it good to go?
Yes.
So that one is still minus 2 roots of 6. Now add apples to apples, oranges to oranges, bananas to bananas. 3 root 5s plus 4 root 6s minus 2 root 6s.
2 root 6.
So this would be 3 root 5s. Are there any other root 5s? Then we have 4 root 6s minus 2 root 6s.
Change the oranges into apples.
2 root 6s, right, everyone? 4 minus 2? Are you guys understanding? And we're done. You cannot add those together. Those are different like terms. All right, so do we need more practice or you get the picture?
No, please give us something harder.
Okay, try that one then. Go. Ready, go. Ready, go.
We got this.
Ready, go. You're going to tell me what the final answer is. Make sure all your radicals are simplified before you start combining. Or you, there's many ways to do this one. Just do what you think you should do. Math is math, so you can do it many different ways. Give it a try. The worst that could happen is you're wrong, and then we figure out what went wrong.
Is that it? Right there.
I don't know, because I haven't done it yet.
Can you guess that it's right?
I can hurry and do it.
Yeah, I'm pretty sure that's right.
Oh, is it just this? Is it just this?
It's this.
What'd you get? Sorry, now I think I have it.
This is what you got. Yeah. You got 6.
Okay.
Yeah.
6 with 5.
Other way.
What'd you guys got?
I got 6 with 5 underneath the can.
Say 6 root 5s. 6 root 5. I'm just helping him state his answer.
6 with the 5.
We're going to try to use correct math lingo, so I'm going to correct it. 6 root 5. 6 square roots of 5. That's the best way to say it.
You got 6 5?
So I have negative 2 square root of 9 times 5. So that's negative 2 square root of 3 times 3 times 5. Yes? Pull out a 3. So that means now I have negative 6 roots of 5. We're going to use correct math lingo in here. So listen to how I said that. That's negative 6 square roots of 5. Now I'm moving on. We have, this is good as it gets. That root 5 doesn't simplify. So I have plus 3 square roots of 5. Then right here I do the same thing. I have 3 square root of 3 times 5. True? Because that was 9 times 5. So I pull out a 3. 3 times 3 is 9 roots of 5. Then I say, okay, I can only combine apples with apples. Negative 6 apples plus 3 apples plus 9 apples is how many apples?
6 apples.
It is. It's 6 apples. So 6 square roots of 5. How many of you got it right? Nice. How many of you are like, I got it wrong, but it was a silly error. I won't do it again. Nice. That's just as good. All right, let's go work. Let's go do these ones.
Oh, he does not want to talk to you.
Okay, focus. You guys, we would have had like at this point 10 minutes of homework if we could focus better. Like we would have already been working on homework for 10 minutes at this point. If you guys would learn to focus between each problem. Here we go. Writing it down. You guys have got to take your own notes in here. Your secondary math 1 teachers must have given you note packets. Right, which is why you guys are used to being babysat and like, write this. Put 2 right here. You got to take your own note. No, take your own damn note. All right, here we go.
Don't say that.
All right, we got this. We're learning how to be college adults. In college, they don't give you a note packet. So we're learning how to be adults here. Take your own notes, and if your notes suck, that affects you. Okay, here we go. When adding complex numbers, everybody, a complex number, stop talking. A complex number has a real part and an imaginary part. It is okay. Think about it. A plus BI is the same thing as BI plus A. Is that true? It is, but it's just more common. Fun fact for you. In math, it's become a common practice to put the real part first. Is it wrong if you don't? No, but I'm going to write it how it's become the common norm in math. We write the real part first and the imaginary part second. These are not like terms. Real numbers are not alike to imaginary numbers. So everybody, let's look at this. If I said to you, add these 2 complex numbers, just because there's parentheses does not mean it's multiplication. Do you or do you not see with your eyeballs an addition sign? You do. So what does addition mean? Add, not multiply. So you combine real parts with real parts. Aren't real numbers able to be added to real numbers? Aren't imaginaries like terms to imaginaries? So just don't overcomplicate it. What's 7 plus 3? 10. 4i plus negative 2i. 4i plus negative 2i. So we have 10 plus 2i and we're done. There's the real part, there's the imaginary part.
I'm really glad.
So it's really easy. Now just be careful with subtraction. Everybody look right here. Now, this is a subtraction problem. There's many ways to think through a subtraction problem. We usually recommend that you take that negative and you distribute it through to what is being multiplied with the negative 1. Now look, I'm going to write my negative 1 right here. So where does the negative 1, what is the negative 1 being multiplied to? 4 and negative 2i. True, everybody? So this didn't change. This is negative 1, and I don't need even the parentheses then. This doesn't change. This is negative 1 minus I, right? There was nothing in front to multiply that to. True? Yeah. Then now what number do we have right here? Negative 4. What number do we have right here?
2i.
Positive or negative?
Positive.
Positive 2i. And now I've just written it out really nicely here. Do you guys see?
Yeah.
It's just recommended to distribute the negative and then write it as you see it. So now combine real parts with real parts. Negative 1 minus 4 is what number? Negative 5. Negative I plus 2i is how many i's?
1.
So 5 plus 1i. Now yes, you can write this. Negative 5 plus I. They're the same thing. Both answers are acceptable. So you combine real parts with real parts, imaginary with imaginary. Let's just be smarter than the problem. Be careful with subtraction. So what do? We distribute the negative, yeah? And then combine like terms. What are your questions on that? Okay, let's go practice the homework problems. I need you doing some right now so that we can get some done in class. Ready, go. So you can ask me for help if you were confused. We've got to get better at focusing in between